to start recording. Hello, welcome to the stream. So today at like 4 in the morning for me, the new version of Bevy came out, and apparently broke YouTube's analytics, which is kind of fun. Wait, why am I not doing anything on screen? There should be something on screen. There we go. Okay. Yeah, so it like actually broke YouTube's analytics. That, or somehow everyone knew that the new version of Bevy was coming out exactly 24 hours before it did, because if we go to my YouTube analytics, ignore this video, we just have a look here and go like my no, analytics last 24 hours, right? See it in bigger, like at exactly 3 to 4 24 hours ago, exactly 24 hours before Bevy came out, a whole bunch of my videos got a whole bunch of views. And I don't know if that's YouTube breaking or something happened automatically 24 hours before Bevy released that told everyone that Bevy was about to be released, or somehow triggered some automatic thing to go watch a bunch of my videos because it detected some kind of thing with Bevy, because it's just on 24 hours before it came out. And then this is, when did it come out? It came out here. So as you notice, there's no actual uptick with Bevy coming out. So it's not like YouTube started pushing my videos or anything. And then this is me releasing a video that is doing quite well at the moment. Anyway. We're live streaming the updates here. Not I've got about halfway through reading these because it's not that it's long. It's just slightly dense in terms of the information. So I'm going to do a live stream because I enjoy live streaming this kind of stuff. Lets people comment if they like want to know my thoughts in more detail, or if they have their own thought to chime in. So I was doing jumping into Discord. So if anyone wants to come in and have a chat, I'll be on the Discord in the lounge. If anyone wants to come have their input on a particular feature. So let's jump into it. So today, Bevy 0.16's come out, because apparently 261 people contributed with 112 pull requests, which I think is Bevy in total, not specifically 13. But they've added GPU-driven rendering, procedural atmospheric scattering, decals, which I want to do a video on because they look really cool. Occlusion culling, which is like a subsection of this, I think, from what I understand. ECS relationships, so they've removed parent-child and replaced it with like a built-in relationship structure, which means that you can actually build your own custom relationships rather than having to reinvent the wheel. You can use the optimizations. Isn't it? Rapier will probably be out in a week because Rapier's really good at getting updated. Let's have a look. Bevy Rapier is like managed by like an actual team. The actual team behind Rapier update Bevy Rapier, so it tends to be quite quick to get updated. Like I'm surprised it wasn't out like on the day, because they, I would imagine, would have a last week updated to this. Does this? We're gonna go into somewhere. Like let's go to 2D and then cargo and go. Hey, Bevy. We're looking for the Bevy version somewhere. The assets, Bevy. So you're right, it's only version 15. Do they have a branch that's 16? Because I'm surprised they did an update last week but didn't. What version are you currently on? Updated Rapier. So this is 0.24. Not correct. We're gonna go in here and go, what version of Rapier up to? So your version 29. So yeah, okay, I guess Rapier's not up to date. It shouldn't take long. I assume maybe they got anything in here. Got really sidetracked on the video that's supposed to be about the update. Requests, update to 16. Okay, so it's like on its way. It's failing the docs and the tests and the WASM, but the Rust format worked. Okay, so it's not compiling, but the 16 version shouldn't be far behind. So master. So we got this person. So if you want to use it, I would assume you can use this person's branch. Or their fork, and you should be able to use it in your current version of Bevy if you actually need Rapier now. But then again, it's not compiling on the main, but I think that's more to do with they have tests and doc checks that are failing, not that the actual code itself isn't working. Because these bigger projects tend to have a much more restrictive way of implementing their code. So you can't just pull code, like Bevy does it as well. Like you can't just push code onto Bevy. It has a whole bunch more checks than you would normally do on a code to make sure it all meets Bevy's restrictions and requirements. Anyway, back to the actual update. You have to edit this all out in the video. It's going to be great. So the ECS relationships, which seem really cool, and they also relate to, I don't think it's mentioned here, immutable components, which I wish I'd known about when I made my observer video, because they're actually relevant to how you can make observers more, what's the word for it? More sound, because you can say that a component can't be modified once it's been added, and therefore the only way to add or remove a component is to specifically insert, which means that the observer will definitely catch it rather than the change detection, which may not catch it. Anyway, improved spawn API, which they say improved. I think it confuses me, but that might just be because I haven't actually used it and their examples are not entirely clear of how it's actually working. It uses a new feature, bundle side effects, which is a bit weird that they you can add the same component multiple times, because when that component's added, it removes itself. It's confusing. I don't quite get it. Well, I guess it's not component side effect, it's bundle side effect, and you must have to make a bundle, and then you can add numerous bundles, but only one of each component. Anyway, it's confusing. Unified error handling, which is going to be amazing for a lot of people that say that Bevy's hard and the fact that they've unified it into a singular thing means that it's much easier to use the question mark operator to return traits up and then have Bevy just log an error. And it gives you the flexibility to crash during development, but only log it during deployment. So it makes the code much better. No STD, which I am super excited for. I don't know if I have the skills for it, but I would love to get Bevy running on a Raspberry Pico and use that instead of, what do I use? I use Embassy, don't I? Embassy. Can we go, I think it's GitHub. Yeah, my GitHub defaults to Embassy. So when I write code for Raspberry Pi Pico, I write it and I have to use Embassy, and I find Embassy really cumbersome to use because it wants you to deploy tasks, and you have to actually actively deploy tasks. I think if we could get Bevy working on a Pico, that you can run Bevy as an RTS instead, an actual real-time operating system that is Bevy. So no rendering, none of that, just you add systems and the systems run like tasks, and that would be amazing. And I really want to do it, because you could have all the peripherals. So here, Embassy, you initialize the peripherals and then you access the peripherals. I can see Bevy doing that. You initialize the resource, and then the resource just does you can, if you need access to this pin, you can remove the resource, that kind of thing. Anyway, that's getting sidetracked, because that's something I really want to see, but I don't know if I have the skill to implement it myself. But hopefully the Pico's popular enough and Bevy's popular enough that someone will do that for me. Anyway, our fast transform propagation. So this is about where I got up to when I was reading before I started the stream, because I like to read ahead so that I can have comments like I'm mentioning here of talking about the actual feature that is implemented, and also just a better understanding instead of trying to read it on the fly, because my reading's terrible. So fast transform propagations, they're saying that they basically optimized it so one, transforms aren't propagated if none of the transform changed, or if something does change, only the parts, they say up, but in my head transforms go down. But so the children of something that got changed will be updated, but the parents won't, because in theory, if you shift a box on top of a box on top of a box, if you move the middle box, the bottom box doesn't need its global transform update. And they reckon that it's 11 times faster, or as they put it, the percentage increase isn't important. The fact it's 11 times faster isn't important. It's the fact that it's 6% of your frame budget was being consumed by transform propagation on that particular scene that they were using, and it's now 0.6% or 0.5% of your frame budget instead of 6%, which is incredible. GPU-driven rendering. The idea of GPU-driven rendering is, instead of the CPU deciding what needs to be rendered when, you load all the data onto the GPU, and then you send the GPU updated transforms, and then a list of things that can be seen. And the GPU is in charge of working out what's occluded, if it's behind something else, what mesh to render, all the that is handled by the GPU, which means that the CPU can be doing other stuff, and it's just significantly faster. And then the GPU also does it in one draw call and has all the meshes loaded in such a way, which is where they So over in the conventional approach, the CPU determines the objects that are visible, through frustum culling or occlusion culling, and then for each object, the I won't necessarily be small. If you go on my channel, you'll find like the last, I guess every update since I think 0.6, I've done one of these videos. They usually end up being 2 or 3 hours, like an hour or two long because of how much stuff is in this. But I do cut out like these tangents and try and make things a little bit more concise. I never used to because I used to not stream them. So I used to just read the whole thing through basically and give my thoughts. But I do intend to edit this down and upload a video that's maybe only an hour long instead of the live stream's probably going to be 2 or 3 because I'm going to do tangents and sidetracks. Like I'll cut all that stuff out about rapier and stuff like that. So back onto the CPU render. So for each object, the CPU will send the transform and like other information to the GPU. Then it'll transfer the mesh data, or I guess just what mesh data because it may already be loaded, and then write the material data, and then tell the GPU the textures and other information like lighting, and then issue a draw call, and then the GPU will actually render the object. So the idea is that a lot of the stuff is done on the CPU, whereas with GPU-driven rendering, the CPU supplies a buffer containing all the transform information and objects. And then if a new object has been provided, it's spawned since the last frame, the CPU will update that particular table to indicate that the new mesh data, like where the mesh data is for that specific object. And then materials will only be updated again if they're modified. Then the CPU creates a list of objects to be rendered and sends that list to the GPU. And the GPU then works out all the stuff that the CPU was previously doing and then renders it. And it says that it can do, like, I think it does a numeral list, multiple lists, but the lists tend to be small. Each object, each object is referenced as a reference. So instead of having to send all this data, you just send a singular number saying point to that data. And the idea is that you have a number of lists depending on the complexity of the scene, but rarely more than 15. So like lots of objects are crammed into a single draw call. And then so it says here for each list, the CPU issues a single draw call, processes all the data in the list, determining which objects are actually visible, which relates back to the occlusion calculations. And then the GPU renders every visible object. They do mention that for larger scenes, this is really good, like up to 3 times performance. But I think somewhere down here they mentioned on smaller scenes, this is not necessarily actually faster because of the extra overhead that comes in, and then can actually slow things down. Was that something else? Maybe I'm getting confused with another point. That might it's the occlusion. So the occlusion culling is something that may actually slow things down because it may be faster to render the object behind than to like a few objects behind other things than to check every object and make sure it should be rendered. That's what. So for large scenes, it's a big speed up, but for smaller scenes, it's less noticeable because there is potential overhead. So they talk about more technical stuff that I'm probably not going to go into because it's a little bit over the top. Maybe just go. Yeah, they're saying that the GPU rendering, GPU-driven rendering is like a bunch of techniques rather than a singular thing, like unified thing. So multi-draw indirect, which I believe is when they talk about you issue a single draw call that points to like an array of different objects that are then all rendered rather than individually sending each mesh. You send an array of meshes and then you point to which mesh you want indirectly, hence they're multiple indirect. And then the bindless resources, which allows Bevy to supply texture for many objects as a group. So I think that this is like the same thing again, but with textures instead of meshes. So they bundle all the meshes into like an array of all the clip meshes directly together, and then each texture can grab its specific thing by indexing into that array rather than using the built-in GPUs like texture sampling, because that requires binding the texture and all this other stuff that is limitations later that we'll see. So GPU transform and culling means that basically Bevy provides the position and visibility of every object, but the actual GPU can then, like, when it applies that to the mesh, and therefore has a much better understanding of what's actually being blocked by other things in the scene, can then block things. The idea being, I guess, so if I had a cube that's
1 by 1 by 1. And then I have a transform that scales it 10 times up. So it's now 10 by 10 by 10. The CPU doesn't necessarily do the rendering and scaling up the mesh to work out that that cube is now blocking something else. Whereas the GPU, because it's going to render, it actually does make the mesh bigger and therefore will know what is blocked by the larger mesh and is therefore better at doing like culling of things behind. And it's the main point here is that it's done on the GPU instead of the CPU. Retained render world is they're saying that instead of updating the data every frame, if it hasn't changed, it just gets to stay on the CPU instead of that. Because from what I understand, the rendering bottleneck for most CPUs, for most GPUs, is actually the data transfer rate between the CPU and the GPU. Like it takes so long to send data from the CPU to the GPU that almost always that is the point that your game will actually stop being able to render better, is because it can't send data fast enough. And so what they're saying is if it doesn't change, it just has to stay on the GPU. And same thing with this cache pipeline specialization, which leverages the component level change detection to more quickly determine whether a rendering state of a mesh is actually unchanged and therefore can optimize not sending it back and forth. And then they've got a list of platforms that it's compatible on and like some caveats. So like Windows and Vulkan is compatible completely. Linux and Vulkan completely compatible. Apparently Mac doesn't have Vulkan, but Metal is only partially compatible. So like they can do the CPU transforms, but they can't do the CPU culling, and bindless is not available. Or it is, but like with caveats. So Bevy supports bindless on Metal, but limits current... are currently significantly the limits. Okay, so the limits are slow. So basically, it's like it is implemented, but it's just not as fast as it would be on something like Windows or Linux. And it's the same thing like with OpenGL, it's not compatible at all. The more bindless, and then they're saying like Android, it's determined based on like what Android phones. Like some phones are compatible, some phones aren't. So they've got like a deny list apparently, which will cause Bevy to fall back on its CPU rendering. So the idea is that like Android, your mileage may vary because it really depends on the type. It's the same as the web GPU, it's compatible, but the web GL isn't. So I don't know. I think WebGL must be the old version because I can't imagine why it's not compatible on a newer API. So web GPU must be the new and WebGL is the old. I was doing benchmarks the other day and I saw that Bevy has an example for both, and like one was significantly faster than the other. Anyway, so in most cases, you don't need to do anything special in order to apply it. Yeah, okay. So what they're saying is that unless you're directly interfacing with shaders in your code, it's a drop-in replacement. Bevy will handle all this behind the scenes, and it'll just be faster. Like there's nothing you have to worry about. If you were dying and you have to do specific things to hook into the API with a custom phase item and stuff like that, but that's all again implementation details. Bevy has resources for porting and stuff like that, I'm sure. And then they talk about what's next, which is it's only supported for 3D pipelines at the moment, but apparently all the techniques, they work really well on 2D. So maybe 17 will mean that 2D rendering is like even faster again, considering that like web's kind of not that fast, very fast on fucking bare metal. Doing benchmarks for someone the other day. But the fact that they may be able to implement this onto 2D and make the rendering even faster again is going to be great. So apparently morph targets aren't currently supported, but it does say that having morph targets, which I'm not entirely sure what a morph target is. It's my limitation knowledge of fucking 3D rendering. So it says morph targets aren't capable to be rendered this way, so they are still rendered on the CPU. But having morph targets in your world doesn't prevent other things from GPU rendering. So it works the best it can. It just ignores things. Also, just in case people don't know, it's really dumb. I can see when an ad plays because I drop from 9 people to 2 people and then it disappears again because YouTube doesn't want me to know that they played an ad. It does tell me that it's going to play an ad, but I have to be paying attention. It's just funny that happens sometimes. Okay, so in future, potential for GPU-driven rendering, it could be ported to platforms. So what it's saying is, at the moment, this list is like, we don't support it at all, we don't support it at all. Or like in Mac's case, it's like, it is supported, but it's just not very capable. They're saying that like some of these ones that they don't support do support some of the functionality, just not all of the functionality. So they will render what they can, as opposed to, at the moment, it's just like all or nothing kind of thing. Okay, So, let my brain catch up to my fucking mouth at the moment. They're watching for API changes. So what they're saying is that Vulkan and DirectX 12 are like implementing new stuff that will then be implemented into Bevy when it's available as an actual API. At the moment, they like may not have some of these features. So future versions will be even more optimized because they'll be able to use more of the GPU code, whereas at the moment there's only so much you can do with the layer of abstraction that's available to Bevy. So next up, procedural atmospheres. Mouthful. Up next, procedural atmospheric scattering. Weird words. So in 0.16, Bevy has now got the ability to simulate day-night cycles. So let's start this video from the beginning. So the idea being that they treat every directional light as a sun, and therefore it will actually simulate like a nighttime haze sort of thing of the sunset, sunrise as the sun goes above and below the horizon. And they're saying that to do the skybox here that you see, what they're doing is they're just adding a skybox that is the stars, and as the sun comes up, it blends to the simulated atmosphere, which makes the sky disappear, like the stars disappear. So you don't actually have to do anything special to try and make stars disappear during the day. Just having a skybox that is what your nighttime will look like, and then the daytime will actually cause scattering to blot out the sun or like blot out the stars, which is what actually happens in real life. So hence, it's pretty cool. And they're saying that like it is fairly accurate because it uses like a p-bar technique. It is correctness. The idea being that like it's actually simulating how light works, but you can obviously tune everything to make it look how you want. So I'm not entirely sure what variables, because here you can see they're adding atmosphere Earth. So you just attach an atmosphere to your sun. Oh, not your sun, to your camera. So you attach an atmosphere to your camera, which in theory means you could also have two different cameras with two different atmospheres rendering the same scene, which would be interesting. Anyway, so you can attach an atmosphere, and then the default is Earth. Like you can specify that. So I'm assuming that they might have other defaults, but maybe they just have Earth for now. But it'd be cool to have like a Mars preset and that kind of stuff. But the idea is you can tweak things like So what they're saying is an example. So for example, a high desert sky might experience less me scattering due to the lack of humidity. So the idea being that like in a desert, the sky looks significantly clearer than in like a rainforest, or you probably won't see the sky in a rainforest, but like somewhere where it's more humid. So you can tweak your settings to give like a true, like a better experience for the specific atmosphere that you're going for. So there's apparently some limitations to be aware of. For example, they don't expect, it doesn't affect environment map lighting and the direction lights and the direct lighting from direction. Okay, and the direct lighting from directional lights on a surface. So the idea is that a directional light is your sun and is therefore lighting the surface, but the atmosphere scattering doesn't actually change that light in any way. So your rendering may have weird reflections because the sky is blue, but the light itself is not blue. So you get weird effects. Somewhere it does say about pink at sunset. I'm trying to find that bit that says, when it's enabled, the primary skybox is overlaid with the updated in real time based on directional light of the scene, on the directional lights in the scene, and the default distance fog is replaced with one that is accounts for directional lighting. So this says that basically objects will fade to blue in the background on a clear day, and they'll be tinted slightly orange or pink during sunset. Also, because the atmosphere is top of the skybox, creating a night skyscape is easy. Just spawn the skybox and it naturally fades away as the sky grows brighter at dawn. Somewhere, I'm trying to find the thing. I'm sure it said that it uses all directional lights, but maybe it's this bit here that I was reading. Based on the directional lights in the scene. So that means that you can, in theory, have two suns because it's using both of them. Like it's actually doing an atmosphere calculation. It's not just rendering something. And they're also saying that like it's really, really fast. It's super fast and it should work great on mobile devices. And the secret source is that the atmosphere is mostly symmetric, which means that they can pre-calculate the ray marches because I think once they've done one side, then they can just mirror it and do the other. Like they don't have to do a bunch of math to recalculate it. So it's like half the rendering time. Okay, next up, decals. Decals are textures that can be displayed or laid on top of a mesh rather than changing the actual mesh texture. The advantage is being that you can dynamically represent player actions like bullet holes in FPSs apparently, or like graffiti is the other thing. I want to say CSGO, like when you spray your tags on the walls, like that's using a decal, so it like projects it onto the wall. And it means that they don't have to dynamically update all the textures. They can just add a decal. Don't need to create an entirely new texture for every combination. Huge number of ways. Okay. So they've got forward decals, which is the idea being, I'm not entirely sure. I think like it projects the decal onto the wall by like, I think it's like a billboarding effect where it puts like a panel. So they say that one of the limitations is that if you look at it from a really steep angle, it can look really stretched and skewed because of how it's calculating the decal. So their suggestion is to make textures that are bigger than the effect. Idea being, I think, with this like graffiti here is like if the decal actually stretches up here, this stretching effect will be less noticeable because the actual scale of the texture will be less affected. And then the next one is clustered decals, which I'm not entirely sure what they're saying because the image here confuses me when read with the text. So the idea is that clustered decals, they say, is projecting from a 1 by 1 by 1 cube onto the surface in the positive z direction. They are clusterable objects, just like point lights and light probes, which means that they only display on objects that are within the bounds of the projection to create a clustered decal, spawn a clustered decal entity. Okay. So what confuses me about this is the image they have here is 1 by 1 by 1 cube, and then these like projections, but it's like they're not saying that you can only project onto 1 by 1 cube. I think what they're saying is here there's a 1 by 1 by 1 cube that is projecting onto the surface that you're hitting in the positive z direction. So the idea is you texture the cube so that face has the decal you want and it projects onto it. And then what they're saying is that you have to actually make sure that the decal touches the cube. So in this example here, the fact that the graffiti doesn't obviously get stuck on the window is because the decal goes through, but it doesn't go all the way to the other wall, which means that it doesn't spray onto it, which gives you interesting effects and very simple to add, just to spawn a cluster decal. Whereas this one I think is a little bit more to create a forward decal, spawn a forward decal entity, which uses a forward decal material and uses a forward decal extension material extension. So not exactly as straightforward. I think it is more straightforward. It just seems more complicated because you need a material and a thing, whereas the forward decal cluster is its own self-contained entity, which probably contains a texture at some point. Anyway, ultimately, forward decals offer broader hardware and device support, while clustered decals are high quality and don't require creation of while clustered decals are high quality and don't require creation of bounding geometry, improving performance. Currently, clustering decals require bindless textures and thus are not supported on web, iOS, or Mac. Forward decals are available for these targets. So weird. I thought it was the other way around, but which is kind of annoying because these ones are definitely the ones I would want to use. But so they're saying like you need to specify some kind of geometry for this somehow. But maybe you don't specify it. Maybe that's calculated by the actual decal code. Anyway, moving on. Experimental occlusion culling. Occlusion culling is the idea that we don't need to draw something that is blocked by another object. Ugh. Yeah, I don't know if I'll leave that. Probably redo that bit. So occlusion culling is the idea that we don't have to render something if it's behind another object. For example, we don't need to draw a person who's hiding behind a wall, even if they're actually within the range that the camera would in fact render them. Bevy already has an optional depth pass filter that can go through a scene. I think it renders at a lower quality. They just say that it's which renders a simple version of the scene, which I assume means lower resolution, not because like how do you simplify a scene without already knowing what you cannot render? Anyway, this can then be used to skip certain objects because when you go through the main pass, you can check to see if the thing you're about to render is in the depth map, and if it's not, then it's behind something else. However, this doesn't skip the vertex shading overhead, so they're saying there's still a lot of compute required to calculate the depth map and or the vertex shading, which is done even when the object is behind the depth map. Yeah, and the depth map check also adds to the overhead. In 16, they added a two-phase occlusion culling. This approach allows them to use... Okay. So in 0.16, they've added two-phase occlusion culling. This approach was already used by virtual geometry rendering and works well on CPU-driven rendering architectures and works well on the CPU-driven architectures that were established in this particular release. For more details, you can check out that pull request, apparently. I don't know why I would. This seems complicated. So now... yeah. So for now, apparently the occlusion culling is marked as experimental, hence the experimental occlusion culling, due to the fact that sometimes it makes mistakes, and I assume renders things that you shouldn't see. No, it must be that it makes mistakes and doesn't render things you should see, because if it did render things you shouldn't see, it's a slight performance hit, not a like, we're going to hide this behind a feature restriction. So what they're saying is that sometimes it just thinks that something's behind something when it's not, and so you have to actually specifically add the depth prepass and the occlusion culling components to your camera. An important note is occlusion culling. This is what I was talking about earlier. An important note is that occlusion culling won't be faster on all scenes. Small scenes won't benefit from the culling as much as larger scenes, and therefore will be slower because they will try and cull more. Technically, they spend more time trying to cull things than they save from things that they end up culling. So the more stuff in your scene, the more likely something will actually get culled and therefore be worth checking to see if it should be culled. And they're saying make sure that you actually check yourself whether your performance is improved. Fuck, my brain does not like reading for like an hour. And it's not even been an hour. It's only been half an hour. So this is fun. Anamorphic bloom. So this is the idea that in old-timey cameras, they would take a wide picture like this and then project it onto film, which was square or, like not as wide as the size of the camera. So if you ever go to a movie theater and you see a movie in 2.34, which is the like aspect ratio is really wide versus the 9:16, they actually used to, when they made film, compress the 234 onto 9:16 film, and so that would squish the bloom because obviously the camera had an equal amount of bloom in every direction, but you've now squished this so that equal amount of bloom, when unsquished, makes the bloom wider in one axis than another. And Bevy is now saying that they allow you to specifically set bloom to be like different in each axis, and therefore can have the this bloom effect. I assume it's also got other things. By setting a two-dimensional scale parameter. That's it. It's a very short section. Okay, now on to ECS relationships, one of the exciting things. When building Bevy apps, it's often useful to link entities together. Most commonly, this is the hierarchy with the parent-child relationship. Components are stored in a list of children for one entity and in a parent component on the other, which points in each direction. This works, but has some glaring downsides. The main one being that the hierarchy... Wait, what? Okay, so one of the bigger downsides was that the actual hierarchy is independent of the core ECS. It's something built on top of the ECS. This has the limitations that if Bevy wants to make specific changes to optimize the ECS around spawning, they can't do that because the hierarchy API, or like the way of adding hierarchies was not compatible with making an API change like that. So there'd be no performance improvement for specifically. They can't optimize for hierarchy because it's independent of the actual ECS. Systems were specialized and not reusable. The idea being that the Bevy hierarchy used parent and children components, and so you as a developer couldn't make your own relationship separately and use some of the built-in like things. So in Bevy 15, if you queried for I think it's children, I guess it depends. If you query for parent, you can then iterate through all the ancestors, and or you can find the root, and it'll go up the parents because it has access to the parents in the query. It can query that query itself, and so there was like a shorthand function for finding the root node and finding all iterating through all ancestors because that like was a standard thing. But the issue with that is that you required, for one thing, a query that either captured every ancestor, I believe, or like just contained parent, because if it had some kind of filter on it, it was possible to miss certain steps in that ladder because they may not actually be in the query itself. So you couldn't reuse this for your own code, and it was kind of limiting, and like you had to make a query specifically for this purpose. And then to ensure data integrity, Bevy had to do expensive deduplicating scans every time you made a modification to the hierarchy, because it needed to make sure that the child you just added wasn't already in the list, and or when you remove a child, it had to make sure that it was gone from the list, sort of thing. So this is the bit that confuses me, because well, actually this doesn't, because this is just defining stuff. It's the down here that this bit confuses me. So the new API works like this. So you can, when you define a component, you can define it's a relationship, and then relationship target being the component on the like parent for this example, that holds all of the children. And so the idea is that you say relationship target is linked by, and then you make the relationship target and you say this is a relationship target and the relationship is liked. And that means that when you add a liked, it will update the liked by, and you can also do weird despawning, that you can despawn all liked and that stuff like that. It's actually really cool. Like, it's a really robust API, and I've only used it in the pre-release stuff, so I haven't actually fully dived into it because I haven't had this to read to know what it actually does. I've just like looked at it and gone, that's actually pretty cool that you can like despawn parents and children like you do. Anyway, moving on. Moving back onto the actual project. So it's really easy to create your own custom relationship, because you just thing with entity, thing without, and I believe there's also an extension to this where you can have likes contains more than like just an entity. Like you can have a, and then you specify here, or like with a macro tag, the specific entity that is the relationship that you're talking about. And same here, where you can say that like you specify the actual list that is the target, and it doesn't necessarily have to be a new type like this. So the way that Bevy handles this is that the relationship component is the source of truth, which means that if the relationship is modified, then the relationship target is updated accordingly. But the relationship target can't be updated to modify the relationship. I'm going to take my jumper off because it's getting fucking hot. So give me 30 seconds. The idea of this is that you can get rid of a lot of the expensive checks for deduping and stuff, because you know that the relationships can only be changed in one direction, and therefore modifying, like any modification to this would be an invalid use, or technically can't modify either of them. It means that the relationship, I guess, it's easier to track and keep maintained, because you know that this changes that, rather than having to make sure that this hasn't already changed that, which is, you know, pretty cool. And then they say, so the relationship's built on top of component hooks. So they use the added and removed hooks, and I guess it must be inserted and removed, or inserted and replaced hooks, so that they can overwrite the relationship with the correct hook, like with the data correctly, and can propagate all that stuff without having to worry about like there ever being a state where the ECS is incorrect, or that where our hierarchy is incorrect. Because with the old version of Bevy, you could modify like a parent, and then the change detection wouldn't pick up on that until the next frame, and that would mean that for a while there, if you queried the parent before the change detection came in, the parent would be wrong. So Bevy's said no, the commands run and the commands apply the change, and then the observer runs and updates the change, or like in this case the hook runs and updates the change, and then that's it. And that ties into the new immutable components feature, which basically says that you can't modify these components once they've been inserted. The only way to change the data is to insert a new copy with the new data. This means that the on add and on replace hooks get called accordingly, and the data is maintained correctly, rather than having to do the expensive change detection. Okay, so what's next? They're planning to add many-to-many relationships. So at the moment, the only relationship you can have is like a parent to a child. Yeah, Bevy 0.1 will be nice when it comes, but I somewhat kind of hope it doesn't come because of the extra restrictions that are added. That'll like just call it, do a Bevy 1 and then just like immediately start releasing these for like Bevy 1.1. Like the big issue for me with the Bevies, everyone's going, oh, waiting for Bevy version 1, is that like the Bevy version 1, I don't know what Bevy would look like to be this is version 1. Like, in theory, you could stop at any version of Bevy and stay on that to develop the game, and outside of third-party plugins not updating, you'd be fine. And even then, it's not like they're going to retroactively remove a plugin. So if you just pick a version of Bevy, it's the equivalent of it being a 0.1 release. I don't know if Bevy has a roadmap where it's like, this is the finished version of Bevy that it would stay on. Especially because at the moment, every minor change is a breaking change. So maybe when it gets to 1, it means that the minor changes won't be breaking changes, but it's a bit weird that 0.1 some milestone that everyone's waiting for. It's more just, I can't picture what a like finished version of Bevy would look like. It's more like, I don't know if it'll ever reach a 0.1 kind of situation. Anyway, so they're going to do a many-to-many relationship, which is that currently you can only do many-to-one, one-to-many, which is that you can have many children, but you only have one parent, whereas a many-to-many would mean that you could have like many friends, and your friends can have many other friends. So that's a many-to-many relationship. And then they're talking about fragmenting relationships. So in the current way it works, the ECS treats all instances of child of to be the same archetype, which means that like from a data iteration standard, they're all the same like bigger object class. And the idea is that in the future, they may make it so that you can say that this relationship actually fragments the archetype, meaning that if you have, say, like a majority of things are a child of one and a majority of things are a child of like a second thing, then that relationship splits the archetype and means that iterating through a filtered thing for that particular child is significantly faster because the archetypes are split, meaning queries can grab only the relevant data where they have a thing that... making access patterns more cache friendly, the idea being, and querying values faster. So the idea being that like you don't have to iterate through everything, you can just grab the archetypes that actually have that specific relationship. I personally don't know where this would be used, but like I can see how this could be something, but I hope it's behind a feature flag and not something that you accidentally fucking stumble into where you split all your archetypes because everything says a different parent. Anyway, improved spawning API. Yeah, actually, just another point. Child is probably the worst example. It should be parent that they'd be talking of. Obviously, you can't add parent when you're spawning a component, but the parent would be a better example because lots of things, I guess that's what it is, child of E and child of E2. They really confused me that they changed the name of that. So I guess what's happening there. So yeah, the idea being that like if you had most things were a child of one, or like half the things are child of one, half the things are child of another, then querying and iterating through things that are child of one would be faster because you only grab components that are child of one rather than all components, all entities, and then having to split the query checking which is which. Anyway, so it's improved spawning API. So I think this is their example of what it looked like in 0.15. Weirdly, they didn't have like a comment thing. Usually they have at the top saying this is 0.15. So the idea was that you could spawn something and then you would with components, and you go right hand, left hand, and then the left hand has a glove. The right hand has a glove and a sword, and then you put on the left hand and it has a glove and a sword or a shield. Like, my brain is just not working at the moment. Anyway, so the idea being that you'd have to like step into all this nesting to spawn everything. So the Bevy's currently working on the editor, and part of the editor is the next gen scenes, and UI, which is by like making everything more user friendly before they release an editor using it. An improvement towards that is making the ability to spawn data like much more easy, as I put it, making it possible to express hierarchies directly via data rather than like a nested implementation like this. So rather than a builder method. The application of relationship further increases the data is built in such a way all relationships can benefit from this. So what they're saying is not only are they making something that's compatible for what they need it to do, it will be available to developers because it'll do anything. So then we say in Bevy 0.16, if you want to do the same thing that you're doing here, you instead say spawn player with children, and then you say right hand with children, and then left hand with children. And so I think this just... Is that? Yeah. Okay. Spawn glove, spawn sword. Yeah. So that's how that works. It's like you specify children, and then you can provide the children that it'll spawn as like an array, and then weird. So then they say saying you can also weird. So what is that? This extends on the bundle API, which now has a bundle effect, which is applied immediately after the bundle is inserted. Notably, this enables developers to define functions that return hierarchy like this. So the idea is that you can write a function called player, you give it a name, and then it returns a bundle that then does, sets up your player. And the idea being that you can have it do all this fancy stuff like set up the children in the hierarchy, and then all you have to do later is just call spawn player, give it a name, and then it'll do everything it needs, which is like a really neat API reduction. And they're saying that in most cases the children macro should be used, but there are other examples, like other places, things you can do. So you can use a spawn, which then has left hand children spawn. It's very confusing. And then you spawn left right. And it says that there's the number of ways to wrap it that provide additional flexibility. So you can spawn and give a component. You can spawn an iterator, provide an iterator of components. You can spawn with, and then say when the parent, and then you have the child spawner, which then allows you to dynamically write some kind of function that determines what children to actually spawn. And they're saying that this also works with any relationship. So the example above where the likes and who likes who and who's liked by who all still works with this same structure, but you have to use the related instead of the children. So children's a shorthand to get rid of the liked by part here. Instead of putting child of, you instead just use children, whereas related, you then have to say liked by, like you have to specify the type that it's using. So they're saying this optimization allows them to optimize hierarchy construction, since the fact that all bar with parent, or like with, all bar the with one know exactly how many they're going to spawn when you add them, which means that the compiler can, at compile time, know exactly how large. I guess it's not just at compile time, but even at runtime, it knows exactly how many you're adding, and therefore can allocate the correct amount of space and use it properly. The spawn with doesn't work like that, because the spawn with, in theory, it doesn't actually know how many times you spawned a child, but I'm sure you could work around that. Or again, just don't use the spawn with and instead use other ways of constructing the data beforehand. So next, onto another big oh, my fucking head starting to hurt. Another big change is the unified ECS error handling. So back before 0.16, Bevy expected the user to work out how they were going to handle errors. But as of 0.16, Bevy has said this is how errors will be handled, which is using the global error handler. And the idea being that Bevy exports a result type, which you can return, and all systems, so systems, observers, and commands now support the result type. So the idea being that you can pop over to here. So it's a system, and I can say, hey, the system returns result. I can spell. So, and that means that it can return a Bevy result. So like a Bevy error, and then a Bevy error is apparently any error type can be a Bevy error. The idea being that you can really easily make systems that you just use the question mark operator to propagate the errors. And then the errors are the idea being, because it's so universal, the errors can propagate really easily using the question mark operator. They have better backtracing apparently than anyhow, because I think the big difference is that Bevy knows what's noise from Rust and what's noise from Bevy, and will strip that out, whereas anyhow won't know that because it doesn't know about Bevy, so it can't strip out Bevy's noise. It'll just have all that in its backtracing. And then because it's all handled by the global error handler, I'm fairly sure the global error handler, if we have a look, once lock function error handle error context. So you can overwrite. Oh, that was incorrect. Do we want to return this, please? Okay. So you can override the global error handler, and so like they're saying here, you have it panic during development, and then you can have it log silently in the background when it's a deployment, which greatly improves the experience for people using your application, since they don't have to worry about the game crashing because you forgot to deal with somewhere where you were unwrapping it. So instead, all errors handled bounced up. Now encourage bubblers to bubble up errors. It's like, so instead of unwrapping, you just bubble it up. And the idea being that most things shouldn't throw an error. Like, you only handle the error if you actually know that the error is going to be, if you expect there to be an error, which also brings us to like the single system parameter that they added, which is really cool as well. Stop clicking on shit. So the error handling's a nice improvement. There was something I wanted to comment about this, but my brain is deciding it's not going to work, which is scary considering we're only about halfway down the page. But hopefully most of that down the bottom here is like lots of names. We'll find out. So the other, I'm trying to think there was something else I know about error handling that I wanted to mention because it was actually kind of interesting. Maybe I'll just read. Can choose whether it's system you have. Yeah, I don't know. It's something, but my brain is just not recalling it at the moment. There was definitely something about error handling that I was going to mention, but outside of it just being very useful to be able to throw errors. I guess also it does unify it in that like a lot of like third-party crates can now throw errors in a way that like you can handle. For example, like observers can write their own custom handler. If they don't specify a handler, they use the global one, but they can actually have their own custom one, which is kind of cool. So Bevy no STD support, which is something that, again, I mentioned at the beginning of the video, I am really excited for because hopefully Pico Bevy. But in this example, Chris here made a Game Boy Advanced run Bevy apparently, so that's really fucking cool. They're saying that like a lot of it had to do with the fact that it needed things like error to become no STD, and a lot of crates needed to be no STD, and so Bevy's been slowly migrating over the last 4 years to a no STD, and then they finally hit the critical mass where the main Bevy crate can be no STD. But not everything's no STD at the moment, but the core crate and therefore like most of the functionality is. So there's just certain things like rendering that are not. So yeah, and that's what this Discord open here is that I'm not going to click because I don't actually know if it's going to show anything inappropriate, but as in like my details, not inappropriate like Bevy's got inappropriate shit. But the idea being that like there's an unusual platforms channel on the Discord that you can go see what platforms Bevy supports now that it's got no STD, which is fun. So fast transform propagation, which I believe is where I was up to before the stream started. So I'm going to get even more incoherent as I get stuff that I haven't read before. But anyway, so transforms in Bevy come in two flavors, global and local. So the global one being the actual world space scale rotation of an object, whereas the normal transform is the relative to the parent, and so hence the local. In order to compute the global, you need to iterate through all of the locals down to that point. So Bevy comes with two improvements. Bevy 16 comes with two improvements for the optimization. So the first improvement is that they just did better at parallelizing. So they run things better. They I guess do a better algorithm for sharing the load, and also they did something about splitting leaf and non-leaf. So the idea being that like all the roots that like don't have any children, so anything without a child doesn't need it to be propagated, and so it can be handled differently. Okay, I guess I don't know. That's what to me that's what leaf versus non-leaf means, like the leaf non-leaf split. But anyway, to optimize coherency. So anyway, they just improved the algorithm better. And then the other one was to save work when none of the objects have moved. So the idea is that they have a single dirty bit that gets propagated through a hierarchy. So if you move an object, every one of its children gets its dirty bit set, which means that when it recalculates the hierarchy, it can skip anything that doesn't have the dirty bit set because it implies that it hasn't moved, and therefore like its global transform won't be different because none of its children or none of its parents have moved, so it kind of changed. So the results speak for themselves, taken together. Yeah. So they're testing the huge Call of Duty map, Call of Duty Zone map. Shows that it takes about 1.1 milliseconds to do all the transform propagation on Bevy 0.15, and then it takes 0.1 milliseconds on the 0.16. So that like it's a huge 11 times performance increase. But again, as I mentioned at the beginning of the stream, the big difference isn't necessarily that it's 11 times faster, but instead that you only have 16 milliseconds to do a frame at 60 FPS, and 6% of that was consumed by doing hierarchy calculations. And that's just insane. But with, an 11 times performance, it's now down to like 0.5% of your frame budget is now used calculating. You can see the huge difference. Weirdly, quite a spread out, whereas now it's quite like efficient, like it's not got a big spread to how long it takes, which is interesting. Yeah. So specular tint map, which basically is that the light that shines off of a shiny reflective surface called the specular highlight. So we see the sun shining off it, can now be tinted. And they're saying that this is behind a feature flag because it's expensive to sample textures like this, and you have to provide a texture that tells it like what color the specular highlight should be at a specific point on a mesh. So cool thing if you're trying to make like a specific scene, but not something that's enabled by default because it's just expensive in most cases. So experimental WESL shaders. So the idea is that Bevy's been using WGSL for a long time, and they've built their own extension onto that, which allows you to say like import like standard parts from other files and like conditional compiling logic and stuff like that. And basically what they're saying is that a new experimental like beyond Bevy things coming out, which is WESL, which does all these extensions onto WGSL that Bevy's basically doing. So it's also backwards compatible in that like anything that's valid WGSL is also valid ESL, which allows for you to basically port your code over unless you were using some of the Bevy specific extensions, at which point like they have a link to how you can change like the migration guide for changing your shaders over. And they're also saying that like this is a very experimental new thing that go share your feedback and it'll likely get implemented because like Bevy's I'm assuming contributing back, and also they seem to be quite open to feedback is what this whole section is basically talking about. But it's just Bevy's changing to a different shader language that is a slight extension of the current shader language just because it's more flexible than the current shader language. So visual geometry improvements, no, virtual geometry improvements. Fuck me, can't read. Virtual geometry improvements. So Bevy has this thing called meshlets, which are the cargo feature according to this, but it's the idea that you could precompile a mesh with really, really high vertex counts into meshlets, and Bevy would then take care of calculating like level of detail and stuff like that. And then would render the actual larger mesh out of these meshlets at runtime without you having to worry about controlling the quality of the mesh. Bevy's saying you can use the pre-existing assets, but if you recompile them, it'll use a better algorithm to try and cluster the vertexes together to make a more efficient mesh. It's also just faster because from what I remember of 0.15's update, there was a few API things that weren't available like in shaders and stuff that have been obviously updated and made available in the last 6 months, I guess, or 3 months. That mean that Bevy is now actually able to utilize a lot of these features. So the virtual geometry is just faster and more efficient, but you don't actually have to do anything to get these improvements. It's just a new algorithm and better GPU APIs. So immutable components, which weirdly is placed below something that refers to immutable components, which is a bit strange for the like layout of the release file, that something is mentioned after something else mentioned it or referred to it. So in 0.16, they added immutable components, which is data that cannot be mutated once it's inserted. So you can't query for a mutable reference to it. It will not compile, which is a great way of doing this because it really leans into that Rust will not compile if you're doing something wrong. And so Bevy is specifically one, this is wrong, do not compile. Anyway, the idea being that you can specify the component is immutable by deriving component and then saying component immutable. Also, you can do it when you implement the component. You can specify a type, and the types are, you can either specify mutable or immutable. This is definitely the easier way of doing it. And the default's to mutable, so basically, unless you're specifically going to do something like this, you don't actually need to worry about deriving this extra bit of syntax. So the example they have here is that there's a sum me component and then a resource that is total sum. And the idea behind this is you can have observers that trigger when you add and when you remove some components and then update the resource. And the main thing here, and this is their example of querying, is this wouldn't work in other versions or older versions of Bevy because you could also access the sum data mutably and modify it there. And Bevy's change detection would pick up on it and you could update it. But you would, one, have no way of knowing what the data was before it was changed, which you can do with this because you removal is run before insert. So you could, so you actually know what the data is when it's being removed, whereas if you change detection, you don't actually know what the data was before it was changed. And the other thing is that it could have changed 2 or 3 times before you got access to it with your change detection system. So this means that no matter what, the change detection isn't required, and so your sum will remain sound and accurate at all times. And they're saying like here, you can read the data, but you can't iterate through the data mutably. It will not compile. And the example they give of where they use it is child of and children, which is the idea that you can't modify the child of. You have to reinsert what the parent should be, and Bevy will take care of updating everything. You don't modify it directly. Okay, this is the section that I was at when I stopped and went to start the stream because I did not realize how long it was going to take me to read this whole thing. I gave myself like an hour and a half and I still didn't make it through. Which shows how much quicker I'm going, considering it's only taken me an hour to get back to this point. But anyway, entity cloning. Bevy now has a first-class support for cloning entities, which it was possible to do using reflection functionality. Wait, well, it was okay. The component implementation was slow and required registered all clonable components and required registered all clonable components. And Bevy's entity cloning is supported natively and is simply just adding drive clone. The component to make it. Okay, so Bevy's added the ability to clone entities, which apparently was doable before with the reflection crate, and you could reflect component, I guess clone, or was you reflect component, I guess, and then that would allow you to clone the component. Now all you need to do is derive the normal clone trait, and this will automatically enable Bevy to be able to clone a specific component, a specific entity and all of its components. What I'm curious to know, which maybe it's answered in here, so create a new potion, add magic as you like, yes, okay. And if and then duplicate all potions. Okay, so yeah, you actually specify just cloning an entity, like you specify cloning. You just specify cloning an entity, and it will go through and clone all the components. I'm assuming all the components that are clonable, and not it will fail if the component is unclonable. Clone and spawn. So I'm assuming it's not going to fail if one of the components on the entity isn't clonable, because that would be really annoying to have to make sure that, especially because you may not be the one adding the component, like it may be some kind of like marker trait from like an editor or something that's tagged on, and then because it's not clonable, it's like it doesn't work when you clone it. But I'm assuming it will clone anything that's clonable, which is kind of cool. Maybe I should read ahead and maybe it'll tell me. So spawns a new entity with all clonable components. Okay, yeah, skipping those that cannot be cloned. If your case requires different behavior, there is a more specialized methods. So clone components clones components from the source entity to the specified target entity instead of spawning a new one. That's cool. Move components removes components from the source entity after cloning them to the target entity. Interesting. Weird way of doing it, but I guess that makes sense. Clone and spawn with and clone with allow customization of the cloning behavior by providing access to entity cloning builder before performing the clone. Okay, so entity clone builder can be used to configure how cloning is performed. For example, filtering which components should be cloned, modifying how required components are cloned, and controlling whether entities linked by relationship should be cloned recursively. Interesting. An important note, components with generic type parameters will not be clonable by default. For those cases, you should derive reflect component to the component and register the entity clone function to work properly. Interesting. Okay. I guess that makes sense because there's no way that Bevy can register a type with a generic, because it won't know what the generic you're using, and it can't register every single type possible, because one, that would be recursive, and also just a huge waste of memory. So it makes sense that like if it's got a generic, you have to actually register it yourself. So in this case, generic component with an I32. Documentation on cloning entries is planned on custom cloning behavior for components and needs further experimentation. How it works. Okay, so there's documentation out there if you're interested. Entity disabling and default query filters. Okay, this is interesting. So entity disabling is to do with the fact that they removed a foot gun, because I was reading through the change log the other day. So Bevy had the ability to spawn or insert, and they're saying there's a really big foot gun because it meant that people were like, instead of somehow flagging a component and being an entity and being like, oh, this is gone, they were like, oh, if it already exists, just give it this. But if it doesn't exist, like, it was a way of spawning, I guess, a specific entity ID with a certain number of components, or with specific components. The idea being that, like, if it already existed, just add them. If it doesn't exist, spawn it with this ID and then add them. And they're saying that this was really slow and imperformant because you were constantly moving entities around, respawning entities. So they're saying that instead, disable the entity. So let's actually see what Bevy has to say about this. So it's represented the disable entity by adding a disabled component. This by default will hide the entity and all of its components from systems queries that are looking for it. Okay, so the idea being that if you put the disabled component onto an entity, a query looking for the entity will not find it. Okay, so this is important. Okay, so this is implemented using the newly added default query filter. Okay, these do what they say on the tin, apparently. Okay, well, I mean, I assume. Every query will act as if they have a without disabled filter unless they explicitly mention disabled, generally via the with disabled or optional disabled argument. Okay, interesting. Because this is generic, developers can also define additional disabled in components, which can be registered via registered disabling components. Having multiple disabling components can be useful if you want each having multiple distinct disabling components can be useful if you want each form of disabling to have its own distinct semantics and behavior. You might use this function for hiding networked entities, freezing entities in an off-screen chunk, creating a collection of prefab entities loaded and ready to spawn, or something else entirely. Okay. Note that the maximum control and exclusion. Note that the maximum control and exclusiveness only the entity that you directly add disabled components are disabled. Okay. Their children and other related entities are not automatically disabled. Disable an entity and its children, consider the new insert recursively and remove recursively. Okay, that's kind of cool. So it's a little bit restrictive and weirdly phrased, but that might just be that I'm fucking been doing this for an hour and my brain's melting. So what they're saying is you can stick on the disabled component, and by default, this will make that component no longer show up in queries. I'm curious if I go back to my little project here and say query. Did they just modify this? No, so the default query filter is actually still blank. Okay, which kind of makes sense for what it says, where it says that you can app register disabling components, being that, like, it's obviously not just a piece of generic that the compiler takes care of, but it's just interesting that they didn't do it there. So the idea being that you can say that a certain component disables, and then you have multiple different ones for like different reasons that something may be disabled that have different behavior for re-enabling them, I guess. And that it only disables the specific entity, which is obvious by the fact that it literally says that it's the equivalent of adding the without disabled the filter. Like, obviously it's only going to target that entity, not its children, but you can use insert recursively or remove recursively to enable an entire hierarchy or disable an entire hierarchy, which is kind of cool. So better location tracking. This one is kind of cool. I've stumbled across this while I was doing research for the observers video, which is that they have made like a really cool way, like an abstraction that uses the Rust compiler to make sure that your code is as small as possible without needing to feature flag something. So Bevy unified data model allows instructions and debugging tools to be written from Okay, Bevy's unified data model allows okay, let's try that again. Bevy's unified data model allows introspection and debugging tools to be written for the entire engine. For example, last releases target change Last release's track change detection feature flag lets you automatically track when a line of source code inserts or mutates any component or resource. Okay, cool. Now it also tracks with code. Okay, now it also tracks with code. Triggering a hook or observer. Okay, trigger caller. Okay. Hook context.caller and trigger caller. Set an entity. Sent an event. Okay, so an event.caller. Okay. Spawn or despawn an entity until the entity index is reused. Okay. Entity ref spawn by, entity spawn, entity gets spawned or despawned by. Okay, that's kind of cool. And as a side effect, this leads to a nicer error handling message in some cases, such as these nicely implemented despawn messages. Entity was despawned by having outgrown its name. The feature flag is now track location. And the way that they do this is really cool. They have a thing in here. No, this is not. This is something else. This isn't. That's the basics video. This is something else entirely. This was the right spot. Never mind. I had query open. That's why I got confused. There's a maybe location. Maybe location. So a lot of things return a maybe location, which as it states here. So the maybe location has phantom data of T, and then the apparently T. Interesting. Okay, and then by default, T is a static string location, and the idea is that it's similar to an option that returns some if the feature is enabled and none if the feature is not enabled. But it's set at compile time, which means that you will get like the functions that you call on this will get completely optimized away by the compiler because they do nothing when the feature isn't set, but they do something when the feature's set. So you can have debugging code that like always runs because it won't be displayed unless you actually got the feature enabled, which allows for like really good error handling that then gets cleaned up entirely for release builds because they don't need to actually contain that data. Okay, so text shadows. Okay, Bevy UI now supports text shadows. That was straightforward and easy. Just add text shadows. Okay, and entity with text shadows can be configured to use the offset the color of the shadow. Okay, I mean, I love that section. Fits in a single slide. Just text shadows. Input focus improvements. Okay, so the concept of input focus is important for accessibility visually and or motor impaired users may have trouble using mice with focus navigation. They can control the UI using only the keyboard. This not only helps disabled users, but power users as well. Okay, I'm not sure how that. I think what they're saying is it allows you to like people that are going quickly, like all of the shortcuts in Vim, that kind of thing. I think that's what they mean by power users. It's very confusing. The same general idea can be applied to game controllers and other input devices. This is often seen in games where the number of controllers on the screen exceeds the number of buttons on the gamepad. Okay, or for complex inventory pages with a grid of items. Okay, so the Bevy Ally crate has a focus resource for had a focus resource for a long time, but it was situated in a way that made it hard to use. Okay, that's been replaced with the input focus resource, which lives in a new crate. Okay, the Bevy input focus. Okay, and now includes a bunch of helper functions that make it easier to implement widgets that are focus aware. Okay. This new crate also supports pluggable focus navigation strategies. Okay, of which there are currently two. Okay, there's a tab navigation strategy which implements the traditional desktop sequential navigation using the tab key and a move console like 2D navigation style that uses a hybrid spatial search and explicit navigation links. That's kind of cool. I'm really interested in this because I was thinking the other day that I want to go back and redo my my game jam game, and I was thinking about like I want to make the UI controllable from a controller. So like the idea being that like you can just press up and down on the controller to go through the different bits of the menu. And I was going, oh fuck, like how am I going to do this? And I was going to do this approach of the explicit navigation links. So the idea being that you can explicitly say like when you're on this, you like, if they press up, down, left, right, which UI element, like, and it links to an entity that's now the new and turns out Bevy input focus, like, it actually has this already. So that's kind of cool. So the idea of this is that it has a specific resource called input focus, and that's what the user is currently focusing on. And then by using navigation, in this case, it's saying tab navigation, which will just, like, when you press tab, it'll go to the next thing in the list, and also a hybrid search algorithm or explicit navigation links, meaning that I'm assuming will be like, this is the size of the box, and then it scans to the left if you press left until it finds something that would be intersecting the box, and be like, that's probably the next thing that you want to select because you pressed left from here. And explicit navigation links being that if they press like a specific direction, go to this entity. So the idea being that, like, they've got like a way of creating non-mouse focused navigation to a UI, which is amazing, because I was actually thinking about implementing this and how I would go about it, and the fact that Bevy's already got at least a framework that I can build off, it's going to be really cool. I like this spatial search idea, because I was stressing about how I would make it so that I didn't have to fucking hard code everything, and that would be probably the right way of doing it. Retained gizmos. Okay. In previous versions of Bevy, gizmos were always rendered in an immediate mode style. They were rendered for a single frame before disappearing. This is great for prototyping, but also has a performance cost. Yep. Okay. It's also really annoying for prototyping when you have to, when you want to render something that you've generated and then you want to render it. You have to re-render it every frame, and you obviously don't want to I think like my Minecraft clone, I was trying to do pathfinding, or I was trying to ray trace, and I wanted to fire the ray, and I wanted to highlight every block that it checked while it was working out the ray's collision. And the annoying thing was I then had to like keep a list of all the blocks that it checked so I could re-render the fucking the gizmo every frame, because otherwise it disappears. With retained gizmos, you can now spawn gizmos that persist, enabling high performance. For a static set of lines, we've measured a 65 to 85 improvement in performance. For example, is how to spawn a sphere that's persistent. Okay, so sphere. Okay, a sphere made of 1 million lines. Okay. Handle. Gizmo assets. Okay. So I guess the idea is that you use the assets to spawn persistent gizmos, and then use the gizmo system parameter to spawn the immediate mode ones. So that's kind of cool. I like that improvement too, because that makes it like possible to spawn like something while you're running an algorithm, spawning in the pieces as you go, and then stop and examine them by moving the camera around, instead of having to fuck around trying to work out how to continue rendering the gizmos. Okay, transparent sprite picking. Okay, so in most cases when working on a game, you don't want to click over the transparent part of a sprite. Okay, to count a click on that sprite. Yeah. So if you click somewhere where it's transparent, you don't want it to count. This is especially true if you're working on a 2D game with a lot of overlapping sprites, which have transparent regions. Okay, yep. In previous versions of Bevy, sprite interactions were handled on a simple bounding box click. If your cursor was within the bounds of the box, it counted as a click. If the box it would block interactions with the sprite behind it, and even if the area of the sprite was fully transparent. Yep. Okay. In Bevy 16, when interacting with the transparent section of an entity sprite, those interactions will pass through the entity beneath it. Okay, and to the entity beneath it. No changes required to your codebase. Okay. By default, pass-through will occur for any part of the sprite which has an alpha value of 0.1 or lower. If you wish to revert back to React, if you want to revert to rect changing for sprite changes or change the cutoff, you can do so by overriding the sprite picking settings. Okay, that's cool. So I'm assuming setting it to bounding box, because an insert resource means it's okay, weird. I was thinking like setting it to bounding box would be a plugin level thing so that it adds the right system, but apparently it does it on like a per frame. So you can actually change it like while the game is running. That's kind of cool. Okay, reflection, function overload. Okay, generic and periodic functions. Okay, Bevy adds support for function. Bevy 0.16 added support for function reflections in Bevy Reflect. Bevy type reflection crate. Okay, this allowed Rust functions to be called dynamically with a list of arguments at runtime and safely. Okay. However, due to limitations in Rust, it was not possible to make these dynamic functions generic. Okay, this meant individual functions had to be created for all desired monomorphisms and manually mapped at runtime. Okay. Yep. While the original Rust limitation still exists, Bevy improves the developer experience by adding support for function overloading. The term function overloading might be familiar to developers from other languages, but essentially it means that one function can have multiple argument signatures. Okay, that's cool. This allows us to simplify the previous example. So instead of having to have individual functions, you can just into function and then with overloads. Okay, the first add acts as the base code, which each overload acts on top of. Okay, when this function is called, the corresponding overload is selected based on the type provided by arguments. And by extension, the fact that the function overload allows for multiple argument signatures, this also means that we can define functions that take a various number of arguments, commonly known as veridict functions. Okay, this allows for some interactions, interesting use cases. Okay, so the player, which has an optional name and health. Okay. Creating a player with one of the following bases of providing arguments: no name and 100 health, a name and 100 health, no name and a custom health, no name and a custom a name and a custom health. So you can say create player. Okay, so player into function with overload string player names. Okay, with overload health. Okay, that's kind of cool. That's actually really cool. So you can curve derivability. Okay, Bevy Math has Bevy Math has collected a sizable collection of. That's a weirdly phrase. Bevy Math has collected a sizable collection of curves and methods for working with curves, which are useful for everything from animation to color gradient to game logic. Okay, one of the most natural and important things you might want to do with a curve is inspect its derivative. Okay. Okay, so curve derivatives is what the name of this section is. Anyway, the rate at which it changes. Yes, that's what a derivative is. You might even be after the second derivative. Ooh, the rate at which the rate changes. Ooh. In Bevy 0.16, you can easily calculate these things. Okay, cubic square. Yep. To curve. Okay. With derivative. Okay. Curve with derivative. Okay. Anyway, we're implementing the required traits for most of our native curve types. Yep. Line material curves which accept arbitrary functions are not covered. Okay, build your own. Yep. Rust does not have a first-class notion of a differential function. As Rust does not have a first-class notion of a differential function. So does that mean that this returns a function that then is used? Okay, that would. Yeah. Okay, asset change query filter in Bevy assets. In Bevy assets are data where we hold a single copy of. Okay, in Bevy assets are data we hold a single copy of, even when multiple entities. Things like sounds, images. Okay, even when used by multiple entities, things like sounds, images, and 3D models. Assets like images are stored in the assets images resource. Entities that have components like sprites will hold a handleton image, which identifies which asset they use. While this works great for avoiding storing tens of thousands. While this works great for storing tens of thousands of ogre meshes in memory while you're making a tower defense, this relatively indirect pattern makes it hard to figure out what an asset. This relatively indirect pattern makes it hard to figure out when an asset that related on your change. Okay. This This relatively indirect pattern makes it hard to figure out when an asset that you're relying on has changed. That's because the handle could change, pointing to a new asset, or the underlying asset could change, modifying the underlying data. Okay, while querying for changes sprite will catch changes to the handle, it won't catch changes to the underlying asset, resulting in frustrating bugs that are hard to detect, and as they only occur when things change in an unusual way. To solve this, we've added an asset change query filter, which works for any type like sprite, which implements the new as asset ID trait, something like query new ABB with asset change mesh 3D. Okay, now just works TM. Okay, allowing you. Okay, right. I don't know. That's confusing because why would you use with? Why is it not just asset changed? Why is it with asset changed? Anyway, allowing you to compute data whenever the underlying asset is changed as any result. For any reason. Ugh, weird. Okay. With asset changed mesh 3D. That's confusing because I don't get why it's not asset changed mesh 3D. Like, why is it with? Okay, anyway. Okay, asset processing no longer auto-generates .meta files. In Bevy 12, we introduced assets v2. This was a complete rewrite of our asset system, which added functionality like asset preprocessing, the ability to process assets more efficient form at development. The ability to process assets into a more efficient form at development time prior to deploying your game. This, however, created .meta files for each asset in your project, meaning when you started using asset pre-processing all the time, your entire assets folder would be filled with these meta files automatically, even for assets that didn't need any pre-processing. Okay, to avoid this pain, enabling asset preprocessing no longer automatically writes meta files. This makes it easier to enable asset preprocessing and adopt it generally. Okay, in addition, we're adding asset server write default loader meta file for path, and asset preprocessing write default meta file from path. Okay, what's the difference? Write default loader. Okay, write default meta file. Right, loader meta file. Okay, to allow users to explicitly generate the default meta file from assets when necessary. Consider enabling asset preprocessing with mode preprocess. Okay, enabling Bevy asset processor feature will now process files automatically for you. Okay. Mesh tags. Okay, Bevy has powerful support for automatic instancing for any entity that shares the same mesh and material. Okay. Okay, right. However, sometimes it can still be used to reference data that is not the same across all instances of a material. Okay. Previously, this required either writing significant amounts of custom rendering code or giving up performance benefits of automatic instancing by creating more materials. Okay. The new mesh tag component allows adding a custom U32 tag to mesh material entities that can be referenced in the vertex shader for a material. Okay, in combination with the storage textures on the shader buffer asset added in Bevy 17. This provides the flexibility. This provides a flexible new mechanism to access external data on a per instance basis and otherwise tag your mesh instance. Okay, spawning a mesh tag with a mesh material entity. Okay, this tag. The mesh tag can be any U32 that is meaningful to your application, like a particular value for an enum or an index into some external data. Okay, look up the tag in the vertex shader. Okay. Look up the tag for the given. Okay, weird. The fuck's a texel? Okay, anyway, so I'm not sure what this exactly does. I think it's just saying that shader, you can now use a mesh tag to tag something that can then be accessed in the shaders. It confuses me because it doesn't explain why they were saying about automatic batching, or automatic instancing, and then being like, oh, now we've got mesh tags, which is like, yes, but it didn't specify how mesh tags are related to the instant thing. I'm assuming it's you can say mesh tag something and then use that somehow to make the batching automatic. I don't know. It's confusing. GPU time steps in traces. If you wish to optimize something, you might first measure and first measure and understand it. When looking at the performance of an application, a trace is a tool of choice. It gives you clear understanding of how long tasks take when it happens relative to other work each frame, and how various threads are used. Read our profiling docs to get started. But until now, it had a critical limitation. Work done on the GPU wasn't shown, forcing devs to pull dedicated GPU focused tools. Okay. And structure the pieces together as and struggle to piece together an intuition for how it all fits together. Okay, in Bevy 0.16, we've connected the rendering diagnostic added in Bevy 0.14 and trace to Tracy. Okay. Creating a coherent picture of all the work that has been done by Bevy application in a single convenient place. Okay. That said, we've only introduced a few of our passes so far. While will improve this in the future, we will need to add spans to your own custom rendering code. And specialized GPU diagnostic tools will allow will always be more powerful, capturing all GPU related work done and providing more detailed information. And then special thanks to the person that did it. Okay. Trait tags on Rust docs. Okay. Bevy provides several core traits that define how a type is used. For example, to attach data to an entity, it must implement component. When reading the Rust API docs, depending whether a type is a component or some other core Bevy trait, requires scrolling through all the docs until you find the relevant trait. But in 0.16 on docs.rs, Bevy now displays labeled indicators with which core Bevy traits a type implements. That's kind of cool. This happens for the traits plugin group, component, resource, asset, event, schedule, label, system set, system parameter, relationship, and relationship target. Okay, this is done now through JavaScript. This should be useful for other REST frameworks other than Bevy, and will work with the Rustdoc teams on how to make this built in and more generic. Get in touch if you're interested with. Okay, so that's kind of cool, because that'll be really helpful for someone like me that like goes through and is like trying to track certain things down, because the Rust docs being like, this is a component, will be like a really nice way of actually seeing that. And by the sounds of things, it's not like something that's specific to Bevy, in that like it's not something that they've done like in the way that Bevy writes docs, that it just shows up. It's something that they've actually had to like implement on the Bevy's Rust doc. Was it Rust.docs, or what was the fucking docs.rs? Docs.rs. Okay, no, I'm going to go to Bevy anyway. It's going to take me to the right place anyway. So it's like it's not something that's on docs.rs that they're hooking into. It's like specifically they've asked them to add some JavaScript or something. So let's look up transform. It'd be good if it was here. See, component. Have a little squiz. Oh, screenshot. So spec that trait.component.html. Yeah, I don't know. It's somehow they're saying it's implemented with JavaScript, so it means that it's not something that you can like. Things like Rapier won't automatically get this, I don't think, because they're saying that like they're trying to make it something that can be done automatically, but yeah, that's kind of cool. Anyway, so what's next? What's next? The features above may be great, but what else does Bevy have in the future? Oh, in flight. Whoa, that's a weird. What else does Bevy have in flight? I guess kind of Bevy bird. Weird. Peeking deep into the mists of time, sections are extra hard when the team is always all volunteers. Okay, yep, that's kind of true. Okay, so you can see some exciting shapes taking, some exciting work taking shape. Weird. I don't know why this person decided to go creative writing on me at the end here. Like, admittedly, yeah, we've got to the only section of the thing where they can. Fuck, man. Oh, we've got the only section where they can do some creative writing, but it just feels so weird for them to like suddenly be all this like fanciful. It's taking flight. The mists of time is like, what the fuck? Anyway, it revamped Observer API. Fucking, of course they're gonna do that after I made an Observer video. Yeah, let's just change everything again. Let's okay. Observers are incredibly popular, but come with some weird quirks. We're looking into smoothing these out and making them easier way to write one-off logic. Okay, for UI. I don't know if this is full logic for UI, but anyway, that's kind of cool. But that is a great place to use observers. It's for like UI, because when you click, it does a thing. Like you can make some pretty cool stuff like that. Anyway, so resources as entities. Such would be would be nice if hooks, observers, relations, and more worked with resources rather than duplicating all the code. Would like to make them components on singleton entities under the hood. I don't know if I like this one. Like, I get where they're coming from, and to be honest, I actually thought that's how this worked, because it's been said in the past that resources are basically just singular entities. But what I don't like is we'd like to make them components on singleton entities. It should be we would like to make them components on a singleton entity, because I want one entity that has all the resources as components, not not an entity for every component. It already drives me spare when I'm using the Bevy editor, please, and fucking observers turn up everywhere, because every time you add an observer, it spawns its own entity, and so they're all just called observer. Like it clutters the hierarchy, and I would rather it be one entity called resources that has all the components than have a component for it. Yeah, it makes sense. So having a singular entity, not multiple entities. But anyway. Because otherwise you also lose that thing of like, that makes it sound like you can have multiple copies of a resource, which defeats the point of resources. They're supposed to be singular. Anyway, a .bsn file format for BSN macros. Okay, with the fundamentals laid, require components implementing spawning and relations. Okay, improve spawning relations. It's time to build our Okay, it's time to build out the Terci and I don't know what this fucking's trying to say. It's time to build out the robust native Bevy. It's time to build the native Bevy scene format. That's confusing. It should Bevy native scene format. No, it should be native Bevy scene format. Anyway, and matching macros derived described here. Okay, so basically they're adding a Bevy scene file for extension that then will hopefully, that'd be cool, because it'd be made by actual Bevy means that it'll probably get like IDE extensions and stuff like that, which will be amazing for like actually being able to write scenes as a file. Anyway, light textures, also known as light cookies. Cookies? I think they mean gobos, but anyway. I mean, light cookies, fucking dumb. Gobo is like a way of putting something in front of a light so that it shines a pattern on the ground. It's called a gobo. Anyway, they're great for everything, dappled sunlight to shadows and shadow boxing. Yep. No. So gobos. Anyway, light cookies. NVIDIA's deep learning super sampling, DLSS, is a neural network powered approach to temporal anti-aliasing and upscaling. Okay, we're working on introducing into Bevy, providing a cheap and high quality anti-aliasing solution for Bevy's current TAA. Okay, on support platforms. Unified volumetric systems. God rays, fog, cascading shadow maps, and atmospheric scattering. There are a huge number of rendering features that fundamentally care about the optical properties of volumes of open air or water. We're hoping to unify and extend the functionality for ease of use and more beautiful physics-based rendering. Okay, nice. Okay, ray tracing foundation. Ray tracing foundations. Foundations. Ray tracing foundations. Hardware accelerated ray tracing is all the rage with WGPU helps. We're really ready to start making the first steps, walking towards a world of dynamically ray traced global illumination. Okay, kind of cool. More game focused examples. New users continue to flock to Bevy and need up-to-date learning material. Our API-focused approach to examples isn't enough. We need to start demonstrating how to use Bevy to do common game dev tasks like making an inventory, saving user preferences, or placing structures on a map. Okay, cool. And then, like all these people, they contributed. It's amazing. I mean, go check out Bevy. 0.16 came out today. About 12 hours ago, by my current time by looking at it. God, my brain has melted after that. I do appreciate everyone that stuck around. This is probably like my biggest stream ever in terms of like viewers continuously. I will at some point be editing this down into a more digestible format. It'll probably, the fact that it's an hour and 40 minutes of the actual live stream, by the time I cut out my rambling and like the tangents I went on, that kind of shit, it'll probably maybe a 40-minute video, I want to say, but I'm probably not going to edit it right away, mostly because my head is killing me, and it's going to be a pain to listen to myself talk for an hour and a half. But I will definitely be doing that. Thank you for tuning in. If anyone's interested in what's happening next, I have somewhere, I think it's this one, BBR. So this is an example of a very simple Bevy game that I've made, like extremely simple. The idea being that it's going to be the first episode of Bevy Basics Remastered, and is designed to more or less show off like what you can expect a game to look like in Bevy, like how, like step by step, this is what setting up a very basic game will look like. So it'll be things like adding your dependencies, which in reality I should probably also say like profile.dev.package. Is that not? It's this, isn't it? What's it called? Opt level equals 3. Now we're not going to save this because I can save it now. Things like adding this to make sure that Bevy runs at optimal compile levels, and then it's like, you know, spawning a camera, spawning objects into the world, moving the player, reading the mouse to update the camera, spawning a ball when the player clicks, and the idea is that I'm going to like introduce each topic, like each point as it goes, to try and show off as much of Bevy as I can in a simple way of like introducing commands, resources. In some places I use things like in a non-conventional way, like the single. I use that a lot, actually. The single thing, which is a query that will only make the system run if only one thing exists. So single doesn't run if there's multiple things. So this query is being used. I'm using a local for the shooting ball. I use a local, and then like when you click, it sets it to 1, and when you if you're holding, it increases it, and when you release, it reads it. The idea being that like it shows off the local and makes like an interesting thing. Like it's a very simple game when it fucking compiles. This because I'm recording. I betcha if I go to here, it's going to be, my hard drive is going to be tapped, isn't it? No, maybe not now. That's also weird. Bevy grabbed the fucking mouse even though I wasn't on it. I have a feeling my hard drive was tapped, which is it's because I'm recording that and compiling at the same time. Anyway, so the idea is that you can click and it shoots a ball, and then it shoots another ball, and it's going to show off like the very simple stuff to get a game going, rather than it is about like showing specific details. And I'm going for a vibe of like, if you think this is interesting, then watch the rest of the episodes as I explain in more detailed systems, components, and I'm going to remake all of the Bevy basic stuff, hopefully in like a more updated style, but at least back up to 16 version. So I might just go through the old videos and like nick the whole script sort of thing, depending on the quality, because I did change my style like after like Bevy basics. Like I want to say like 10 was the input stuff, and I think after that I changed the style a little bit, because the input stuff I like wrote the scripts and everything, and then went on holidays and came back and did it differently after that. Anyway, so where's my thing I wanted to show off? Here, so this is the new intro for anyone that like, this is getting really like into the like Bevy basic stuff. It's going to not work because I've got a little bit of sound that doesn't, it it gets stuck because it gets to the end of the sound and the side. So anyway, so we get the little animated intro. So it does this and it does that, and then just click past that because and then it does this and it does that, and it goes over here and then over to the console. It took ages to fucking program this, and it's completely unnecessary. Anyway, so it gets the current Bevy version, and then it like adds the host, and then opens this up, that's me, and then we get a cargo run, and then this does a little like thing, and it's I clicked off somewhere. It's always back here. Okay, so it does that, and then once the correct logo is done, it does this, and then as it loads, it rewrites the name up here, and it does. And then once it's open, and weird. And then it gets to open intro and then it zooms in. Anyway, what makes this really fancy, for people that actually care about this stuff, is that it's done somewhat programmatically. Like it was obviously 3 animator, so it's motion camper. So like a lot of the stuff, it's all defined programmatically. But like I want to say it's down here somewhere. This bit. So it reads how many thumbnails are in this folder. And it then will go through in sets of 12 and animate the thumbnails appearing and disappearing. And then when the correct thumbnail appears, it gets to this bit. When if target is here, so this is the adding the animation here, and it says if the picture that you've just added is the name of the video so basically when you create the animation, you specify here the topic and the Bevy version, which is like animated in. When you specify that, when it finds that thumbnail, it stops changing the thumbnail. It will then, break out of this loop and stop loading new thumbnails, and then does a little animation where then it works out where that thumbnail is, moves the mouse to that thumbnail, clicks it, causes that thumbnail to move to the big, so it's all programmatically decided animation-wise, like this bit. So basically, you'll see it does this, and then it loads this page, and then it's because that's the thumbnail we're using. It will now move the mouse to that thumbnail, click it, make it bigger, and then do that, which is, it's kind of cool. I like it. It's fun. It's all a little silly. I spent like fucking 6 hours or something doing that, maybe more. But it's reusable. So if I wanted to say at the top of the page, it says Bevy ZTB entity, I can change... if I change, we go here and we say, I don't actually know what thumbnails I've got. We'll just say Pong. I wonder what it'll find if I say Pong. So we just say Pong, and then we go back here, and we go, oh, it didn't like that. What do you mean? Oh, well, I broke it. We go back to that. Do you work again? I don't think you should. Okay, you do work again. But don't I just scan? Maybe it's that ends with no. I'm sure I just ask it if it contains it. Length topic. So topic is get topic BRB. Yeah, video list includes topic. So one of these definitely said Pong. So it should have worked. UTDG. Let's try that. Who knows what thumbnail will open though. UT Untitled Dinosaur Tycoon game. If I save that, is it going to work now? It did. So then, yeah, so then we go here and it does the loading again. And the loading, I think, just loads alphabetically. I don't know how Python imports, but the idea being that like it should be able to just pick whatever thumbnail I want it to pick. Kind of cool. It picked the live one, which is, I think, incorrect, but anyway. Because it obviously, like, you don't want to be reusing names of thumbnails. And the idea is, like, because I was obviously using that for testing. Of the 4 people that are sticking around to watch me, like, fucking talk animation stuff. The idea is that it will start with 0 pictures, or like it'll only load the first thumbnail for the first video, load that, then it'll open that. And then as I do more and more videos, like the more and more thumbnails will be there. And the idea being that like it should be like a kind of a cool little nod to the fact that the series is progressing. And then I guess when I update the Bevy version, maybe I should put like in the thumbnail name the version, and therefore when the new version comes out, like I can tweak it so that it doesn't show thumbnails from old versions. It'll also mean that I need to make 2 thumbnails, one thumbnail for the thumbnail that gets loaded here and the actual thumbnail of the video, because obviously I don't need the Bevy Basics on this thumbnail. I don't need the version on this thumbnail. I don't need me on this thumbnail, because that's all in this section of the screen. But the actual thumbnail upload to YouTube, I was originally thinking just that is the thumbnail for YouTube, which would kind of work and it would actually be kind of cool, especially if I numbered the thumbnails so that they end up actually in order. Is it like a screenshot at like this point and be like, that's the thumbnail. But again, got to trim all that stuff out. Would probably also want to put relevant text here. But that would probably be how I generate thumbnails. That is the thumbnail, and then whatever picture I put here is anyway.
If anyone has any animation skills, I would appreciate someone to help. But
I will hopefully be doing Bevy Basic stuff. But again, that's a, like, at the very least tomorrow before I work on this video, because I'm tired. Anyway, thank you all for tuning into the stream. I will see you in the next stream when I probably do maybe some development for Hextra Dimensional. I want to make like the UI, especially because Bevy added all that functionality to focus stuff, and I want to make like the UI feel like really, really good. And I don't remember if I added it to Hextra Dimensional like officially, but I want to have the input manager work that like you can rebind keys very well. Like at the moment it was a bit janky, I think, when I left it. So I want to make that as like a thing that works really well. But that's next time. So thank you all, and I will be leaving now as soon as I work out to stop the stream.